Number 9, a pumpkin launched at an angle of 35 degrees with a speed of 94 feet per second. Determine the maximum height. Okay, we had some special equations for projectile motion like this, but it all boils down to working with the x and y directions independently and using constant acceleration equations. So let's look at the y direction here. So we'll have our pumpkin. We are launching it with a velocity 94 at an angle of 35. Okay, so if we use standard x and y, we can get the y velocity initially to be 94 sine 35. Okay, that number comes out to be 94 sine 35, 53.92. Okay, now we can use constant acceleration equation to look at where we are at a certain velocity. Okay, and we know that the other key to this problem, max height, means the velocity in y is 0 at that point. It's changing directions. Okay, so we know a final velocity, we know an initial velocity in the y direction, we know acceleration y direction. We want to find the change in displacement or change in y. So we had an equation something like this, where those are y velocities and a y acceleration. So again, refer back to constant acceleration equations, determine what you want to solve for, which in this case is this, and what you know. We know the velocities and the acceleration, so we can solve for this unknown here. Okay, plugging in some numbers, our final velocity was 0 at the maximum height, our initial velocity 53.92. That's going to be squared, and twice the acceleration. We're working in feet per second, so we're going to use a minus 32.2. Okay, and coming back to the calculator, let's see, the negative signs on top, a negative sign on bottom, those will cancel out. We'll just square our previous value and divide by 2 and divide by 32.2. 45.1 is the max height of that pumpkin shot at that angle. That's in units of feet.